Assalamualaikum. I'm Engineer Hamna Shakil. In this video, we will solve problem number 106 that is related to normal stresses. The problem statement states that the homogeneous bar shown in this figure is supported by a smooth pin at C. So you've got here a smooth pin at C and a cable that runs from A to B around the smooth peg at D. So you have got a cable AB that is starting from A and that is running over this smooth peg at D and then is connected to a point at B. Find the stress in the cable if its diameter is 0.6 inches. So the diameter of this cable is 0.6 inches and the weight of the bar is 600 pounds. So the weight will be acting at the center of the bar and the weight is 600 pounds. You have to find the stress in this cable that is running from A to B. So stress in the cable is equal to the load on the cable divided by area of the cable. So here you can see that the weight of the bar is acting downward and is stretching this cable AB. So the tension is being developed in the cable. So the stress in the cable becomes tensile load in the cable divided by the area. If we draw a free body diagram of this cable, it will be like this. You have got a hinge at C. The weight of the bar is acting downwards. Here at point number B, there is tension in the cable. You can represent that tension by T. And here at point A, again, you have the same tensile force. The tensile force here and here is the same because this cable is running over this peg. So this is basically the same cable. So whatever tensile load you represent here will also be represented on this side. So now you have got your free body diagram. We can solve this diagram to find the value of tensile load and we can use this value of tensile load to find the stress in the cable. To find the value of this tensile load, we can either use the equilibrium condition sigma fx equals to 0, sigma fy equals to 0 or sum of moment equal to 0 because the system is in equilibrium. To apply any one of these equilibrium conditions, first you have to resolve this t into its component. So it has got one component in the x direction and it has got one component in the y direction. And at the C point, you have got a hinge connection. So you have got one reaction force in the vertical direction and one reaction force in the horizontal direction. If we choose this equilibrium condition to solve our problem, so here Tx is unknown and Cx is also unknown. So we cannot use this one to solve our problem. If we use this equilibrium condition here again, Ty is unknown and also Cy is unknown. So we cannot use this as well. So we are going to use this last equilibrium equation, that is sum of moment equal to 0. And if we take the sum of moment at point number C equal to 0, we can easily solve this problem. Let's write the equation for sum of moment at point C equal to 0. So this Ty force is causing a clockwise moment. So this will become Ty multiplied by this whole distance from T to the C point, which is 10. Plus this T force is also causing a clockwise rotation. So it will become T multiplied by the distance between this point and C, which is equal to 5 foot. This weight force is acting downwards, thus causing an anti-clockwise movement. So you can write minus 6000 into, that is the weight of the bar, into the distance between this midpoint and this C point, which is again equal to 5 foot. This will be equal to 0. So you have got the equation for sum of moment at C equal to 0. To further solve this equation, you need to know the value of Ty. To resolve this T force into Ty and Tx, you need to know the value of angle here. So this angle is the same as this one. So from here you can see that tangent theta is equal to 3 divided by 5. So from here you can say that angle here is equal to tangent inverse 3 by 5. So this Ty is equal to T sine of theta, and this Tx is equal to T cos of theta. We only need to find the value for Ty. So you can write that Ty is equal to T sine, and instead of theta you can write tangent inverse 3 by 5. So plug in the value of Ty in this equation. It will become 10 T sine of tangent inverse 3 by 5 plus 5T minus 30,000 equal to 0. Solve this equation on your calculator and you will get the value of T as 2957.13 pound. So you have got the value of T, and now you can use this value of T to find the stress in the cable. So stress in the cable is equal to T divided by area. The value of T is 2957.13 pounds, and the area is pi d square by 4, because we have a cable and the cross section of the cable is a circle. The value of D is 0.6 inch. So you can plug in the value here. Put this in your calculator and you will get the value of stress as 10,458.72 pounds per inch square, and you can write it as 10,458.72 psi. So this is the value of stress in the cable.